Welcome once again. We're going to begin discussion on a brand new topic, and that's electrophilic aromatic substitutions. We previously looked at nucleophilic substitutions, but this time around we're going to discuss how we can substitute an electrophile onto a benzene ring. Okay, now what is an electrophile? An electrophile is just a substance or reagent that's deficient of electrons, or it's usually positively charged. I do not know of too many neutral electrophiles, but electrophiles are typically positively charged. Okay, and we're going to look at 5 reactions under this category. I am only going to show you the mechanism for one of them because I don't want to make the videos very long by doing mechanism for each one, because the mechanism for the other 4 reactions are exactly the same, the only difference being the reagents used and the electrophile that will be generated. Once the electrophile is generated, you can pretty much replicate the mechanism that I show for the first reaction onto the remaining 4 of the reactions. So we're going to look at aromatic halogenation, nitration, sulfonation, alkylation, and acylation. Alkylation, also known as Friedel-Crafts alkylation, and acylation is Friedel-Crafts acylation. These are the 5 reactions we're going to look at under this topic. And the first reaction obviously is aromatic halogenation. As you can see, we're starting with a benzene, and then it's reacting with Br2 and FeBr3. What happens here is when Br2 reacts with FeBr3, it produces, you do not have to memorize this, nor it's that necessary that you know all of this, but at least know for one of them, okay? Plus Br plus, okay? So the Br plus is the electrophile right here, okay? This is what's going to interact with the benzene ring. Now what happens here is, in chemistry, whenever a bond is lost, that element gets a positive charge. Whenever an element receives a bond, it usually gets a negative charge. It's just that simple. And this is also a case of contagious, you know. So the Br plus is the electrophile, right? It reacts with the benzene ring by drawing out one of the bonds. It really doesn't matter which of the 3 double bond it wants to pick. They're all identical. It just picks out one to make the connection. It's trying to connect the benzene ring with the Br. And the way it does that is it uses the double bond. So the double bond makes a connection between one of the carbons in the benzene ring to the Br. And what happens in the process is you can really attach the Br either to this carbon or this carbon. It really doesn't matter because they're identical, okay? So I am going to just attach the Br to the bottom and then the plus to the top. Now, don't get obsessed. Why should it be top? Why is not the bottom? It really doesn't matter, okay? For convenience, since I'm used to it, I'm doing it this way. You can put the Br here and the plus here, but be consistent, okay? Now, we could basically, if you'd see that we had hydrogens here to start, right? So hydrogen, there's hydrogen here, and there's also a hydrogen here, right? Let's be consistent. Now, as I said, we can circle the positive charge around by bringing the bond here. That means the positive charge would go to the tail of where the double bond was. Remember, that's how we learned resonance, right? So technically, the Br stays in the same exact spot, okay, with the hydrogen. The hydrogen stays in the same exact spot. It's just the bond has now come here, and the positive charge would go to the tail, and this bond stays here. This is one of the resonance structures. We can continue this process by moving the double bond to one more adjacent carbon, and the positive charge would come to the tail of where. So basically everything stays, it's only the only thing that's moving one at a time is your double bond, okay? So HBr, right? And then your double bond is here now, and your positive charge is here. You know, this is the 3 resonance structures, okay? Now, you can literally pick any one. I'm just going to go back to the starting one that I generated to complete the reaction, okay? So I'm going to redraw this one right here, the one we just generated first, okay? Right? So what happens now is we have to get rid of one of the hydrogens here, right, to generate the double bond back. So if you remember, the FeBr minus is still here, right? It's floating around, right? That comes and grabs this hydrogen right here, and this bond comes back. Whenever bond comes back, it brings a negative charge, which neutralizes this positive charge. So that means we will basically have, so we did all of this just to generate a Br. So basically, we are adding a Br to the benzene ring. That's all we did, okay? Now, this is the product. Now, you could also wonder, could I have put the Br anywhere? Yes, the Br could have gone to any of the 6 corners of the benzene ring. So this is just the other, if you had put it anywhere else, it's same as this one because it's identical, okay? So I have told you this, right? So basically you're adding a Br to a benzene ring. That's halogenation, okay? So this is nitration. So again, when you're given an NH, nitric acid and sulfuric acid, HNO3 plus H2SO4 generates NO2 plus, okay? This is what is going to get added to your ring, okay? NO2 plus. So the benzene ring reacts with NO2 plus. You can draw the resonance structures at your leisure time, but that's basically going to react with the benzene ring, and all we are essentially doing is adding a NO2 to a ring. You could have added any corner of this ring. We are going to learn something called effect of substituents. That will be a brand new topic. So where we will learn, what if there is already a substituent on the ring, then we will force the NO2 to go to a certain position on the ring. Right now we're dealing with just plain benzene ring, so it doesn't matter where the NO2 would go. So when you have these two reacting, so nitric acid reacting with sulfuric acid, of course you do have to remember this, that is you're generating NO2 plus. I will not give this to you anywhere because that's part of the learning process. So the NO2 plus is the electrophile that's generated, just like we generated. But here's what I want you to do. I want you to practice and show me the resonance structures. Show the resonance structures. What do you need to do? You need to go back slightly in this video and watch how I drew the resonance structures when I was doing the Br plus. You kind of do the same thing for this reaction. I just show you the final product. So all you do is basically add the NO2 to the ring. All right, I'm going to stop this video here. So this will be part of your My Thoughts. I want you to show the resonance structures on your My Thoughts for this reaction. Okay, I've already shown the product, so you do not have to do that, just the resonance structures. All right, so I'll see you back with another reaction in this reaction category.